All right, we want to talk about long division, but we want to talk about long division when we have decimal numbers, which is a little trickier to do, but with the same rules that we use for whole numbers, we will be able to long divide with decimal numbers too. So a couple of things to remember. First of all, don't forget that ducks must swim backwards. Remember, that's an acronym to remember the steps of long division. We divide into, then we multiply, then we subtract, then we bring down, and we repeat the steps when necessary. So what's the same about doing long division with decimal numbers when you compare it to whole numbers? Well, we follow the same rules. Well, that's good to know. It's good to know that we don't have to learn any new rules. We can use the same ones we already know. The second thing that's the same is we need to be careful with our work to avoid possible mistakes. There's a lot to keep track of. You want to try to be as neat as possible so that we can minimize simple mistakes. Okay, so if the rules are the same and being careful is still important, what's different about long division with decimal numbers? Well, first of all, we need to make sure that the divisor is a whole number. Secondly, we always need to make sure that we move the decimal point straight up in the quotient. Finally, we need to annex zeros in order to write our remainder as a decimal number. And we did a little bit of that with whole numbers. And there are three things that might happen after annexing zeros. I could get a decimal that stops or terminates. I could get a decimal number that repeats a pattern. Or I will get a decimal that goes on forever and needs to be rounded. And we'll touch base on these differences as we do our examples. One thing that would be helpful for us to think about before we get started is about what you can do to a division problem to change what the problem looks like but not change the answer. For instance, what is the answer to the problem 10 divided by 5? I think we all know that the answer to that problem is 2. What happens if we multiply 10 and 5 both by 10, giving us the new problem 100 divided by 50? How many times does 50 go into 100? 2 times. Okay, what happens if we take 150 and divide both of those by 10? That would give us the problem 1,000 divided by 500. How many times does 500 go into 1,000? Holy mackerel, it's 2 again. If you multiply both the divisor and dividend of any division problem by 10, you will always get the same answer. Cool beans! Okay, let's look at our first example of long division with decimal numbers. Let's do 4 and 68 hundredths, 4.68, divided by 2. First of all, is the divisor whole? Remember, the divisor is the number that's dividing into. That's the 2. So is the divisor whole? Yes, it is. Because the divisor is a whole number, we don't need to change it. So we go to our long division problem and make sure that our decimal point moves straight up to the quotient. Now we complete the long division problem exactly like we would do it if it was whole numbers. 2 divides into 4 2 times. 2 times 2 is 4. Subtract. 4 minus 4 is 0. And bring down the 6. 2 divides into 6 3 times. 2 times 3 is 6. Subtract 6 and 6. You get 0. Bring down the 8. Now that we've brought down the 8, how many times does 2 divide into 8? 4 times. Multiply 2 and 4, and we get 8. Subtract 8 minus 8, and we get 0. And there are no more digits to bring down. We've got no remainder down here, and so we have our final answer. 2 goes into 4 and 68 hundredths, exactly 2.34 times, or 2 and 34 hundredths. Nice job. Okay, let's look at the next problem, example 2. Is the divisor a whole number? Well, the divisor is 0.5. That is not whole, which means we're going to have to multiply by tens to move both of the points. What I mean by that is I take 0.5 and I multiply it by 10, which makes it a 5. Then I multiply 4 and 85 hundredths by 10, and it becomes 48.5. And then I bring the decimal point straight up into the quotient. Now I'm basically doing the problem 48.5 divided by 5, which is going to give me the same answer as the original problem, which is very cool. So let's do it. 5 does not go into 4, but it does go into 48, about 9 times. Next is the multiply step. 5 times 9 is 45. Then we move on to the subtraction step. 48 minus 45 is 3. And then I'm ready to bring down. I bring down that last digit, which is a 5. Now I go through my steps all over again. 5 divides into 35 7 times. Then we multiply 7 times 5. That's 35. We go to a subtraction. 35 minus 35 is 0. And there are no more digits over here to bring down, which means this problem is done. No more digits to bring down, no remainder. We have our final answer. 5/10 goes into 4 85/100 exactly 9 7/10 times. All right, let's go on to our next example, example 3. 8 34/100 divided by 300. Is my divisor a whole number? No. That means I need to multiply by tens to move the decimal points so that my divisor is a whole number. So 300 goes into 8 34/100. I need to move the decimal point 2 places to be a whole number, which means I multiplied by 100, which means I need to move the decimal point 2 places in my dividend. We will move that decimal point straight up into the quotient. And let's go. So 3 divides into 8 2 times. Multiply 2 times 3 and we get 6. Subtract and we get 2. Bring down the next digit. 3 goes into 23 about 7 times. Multiply 3 times 7, you get 21. Subtract 23 minus 21 and you get 2. We are ready to bring down the next digit, which is a 4. 3 divides into 24 about 8 times. 3 times 8 is 24. Subtract 24 minus 24, and you get 0. I've got no more digits to bring down. I've got no remainder here. That means our problem is finished. So 300 goes into 8 34/100 exactly 278 times. Example 4. 75 175 thousandths divided by 4/10. Is the divisor a whole number? No, it's 0 4/10, which means we're going to have to move decimal points. So 0 4/10 goes into 75 175 thousandths. I'm going to multiply 4/10 by 10 to give me 4, which is a whole number. And since I multiplied that by 10, I'm going to multiply this number by 10, which basically gives me 751 75/100. This problem will have the same answer as my original one. All right, let's go through our steps. 4 divides into 7 one time. 1 times 4 is 4. We can subtract, and then we can bring down. And we go through the steps again. 4 goes into 35 about 8 times. Multiply 4 times 8, you get 32. Subtract 35 and 32, and you get 3. Now we bring down the next digit, which is a 1. 4 goes into 31 about 7 times. 4 times 7 is 28. Subtract, and we get 3. Bring down the next digit, which is a 7. And back to dividing into. 4 divides into 37 about 9 times. 4 times 9 is 36. Subtract 37 and 36, and you get 1. And we still have one more digit to bring down, which is a 5. Divide 4 into 15. It goes in 3 times. 4 times 3 is 12. Subtract 15 and 12, you get 3. And we have no more numbers to bring down. No more numbers to bring down, but we still have a remainder. So because we're already to the right of the decimal point, we're just going to annex a 0. So we annex a 0 and bring it down, and we get 30. And of course, 4 goes into 30 about 7 times. 4 times 7 is 28. We can subtract 30 and 28 and get 2. This problem is still not done, but if you look at our answer so far, 187 and 937 thousandths, you'll see that we have actually gone far enough to round to the nearest hundredth. Right now we have 93 hundredths. I'm going to look to the right and see that the thousandths place has a 7 in it. That's greater than 5. It's 5 or above. So we're going to give our 93 hundredths a shove and add 1 to the hundredths. This will give us a final rounded answer of 187 and 94 hundredths. Example 5 and example 6 are going to be problems where you need to be careful of what's called a double bring down. And I will point it out to you when we get to it. In example 5, the divisor is not whole. And so we're going to have to move the decimal point. So we will multiply the divisor and the dividend both by 10, moving the decimal point once, and we are ready to go. I know 66 divides into 70 one time. We multiply 66 times 1 and we get 66. We subtract 70 and 66 and get 4. And then we bring down the next digit, which is a 4. Now this is where we need to be careful, because right here is the number 44. And we're trying to see how many times 66 divides into it. Well, 66 does not go into 44. So we need to put a 0 in the quotient and bring down another digit. There is no digit here to bring down, so we're going to annex a 0. Now when I bring down that 0, if I show arrows when I bring down, you'll see that I have 2 arrows right next to each other. That's why we call this, or I call this, a double bring down. So how many times does 66 go into 440? My guess is it goes about 5 times. So now I multiply 66 times 5. 6 times 5 is 30. 6 times 5 is 30, plus 3 is 33. And I can see already that 440 minus 330 is going to be over 100, which means 66 could have gone in at least one more time. So let's divide 66 into 440 6 times. 66 times 6. So 6 times 6 is 36. 6 times 6 is 36, plus 3 is 39, and that looks closer. So we will subtract 440 minus 396, and we get 44. Well, there's no more digits to bring down, but we still have a remainder, and we haven't gone out to the thousands. So let's annex a 0 and bring it down. How many times does 66 go into 440? Wait a second, that looks familiar. We just did that. Well, we know it's going to go in 6 times. And so 6 times 66 is 396. We subtract and get 44. And you might be noticing that if we annex another 0 and bring it down, we are going to get 440 again, which means we have found a very special decimal number. Answer here, it is a repeating decimal. If we keep doing this problem, we're basically going to get 10.66666666, etc., etc. When that happens, we can actually write our answer with a repeating bar. So when you see this answer right here, 10.6 with a line over the 6, that just means that the 6 goes on forever. And it was the most precise way to write this answer. In example number 6, we basically are trying to figure out how many times does 2 4/10 go into 82 and 814 thousandths. The divisor is not whole, which means we're going to have to move the decimal point. So we will move each decimal point over to the right once by multiplying by 10. And then we follow our simple steps. Once again, ducks must swim backwards. 24 does not go into 8, but it does go into 82 about 3 times. Multiply 24 times 3 and you get 72. Subtract 82 and 72 and you get 10. And we are ready to bring down the next digit, which is an 8. How many times do you think 24 goes into 108? How about 4 times? 4 times 24 is 96. Subtract 96 from 108 and we get 12. And then bring down the next digit, which is a 1. All right, let's go back to dividing into. 24 goes into 121 about 5 times. 5 times 24 is 120. Subtract 121 minus 120, and you get 1. Bring down our last digit, which is a 4. And 24 does not go into 14. So we can annex a 0 and bring it down, which is a double bring down, so don't forget to put a 0 in the quotient. Now, how many times does 24 go into 140? 5 times. And 5 times 24 is 120. Subtract 140 minus 120, and you get 20. And even though the problem is not done yet, we have gone out to the thousands place, so we've gone far enough to round this answer to the nearest hundredths. Our answer so far is 34 and 505 thousandths. That means we've got 50 hundredths so far. I look to the right in the thousands place and I see 5 or above, which means I'm going to give that 50 hundredths a shove. So my final answer is going to be 34 and 51 hundredths. Now see if you can do problems 7 and 8 on your own. Pause the video here while you try them, and then after you get your answers, press play and see if you got the same answer. Now you're ready to do some practice on your own. Go get 'em!